Okay, this problem gives us a choice between two reactions, and it says which one of these will go faster in an SN2 reaction. It's not actually saying what will be the mechanism. It is specifically saying, okay, if there is an SN2 reaction, which one of these would be faster and why? And so what's the difference? The difference between the two reactions is only the solvent. And so we've got dimethyl sulfoxide and ethanol. And the difference between those two is that one is protic and one is aprotic. They're both polar. So DMSO is considered polar aprotic and ethanol is considered polar protic. And what this does is it has differences in solvation for the cation and the nucleophile, the attacking anion. And so remember that solvation leads to a decrease in energy, and a decrease in energy is a stabilizing effect. But when we're talking about the speed of a reaction, the faster reaction has the smaller activation energy. So if a set of reactants becomes lower in energy and it's leading to essentially the same transition state, then what we get is a situation where that reaction is slower because the reactants are more stable. All right, so let's take a look at the solvation. What's up with the polar protic solvent? Well, the polar protic solvent has electrons on the oxygen and they can stabilize the sodium ion, but they also have hydrogens, protons, and those protons can stabilize the negative charge of the F oxide ion. Alternatively, for DMSO, it can only stabilize the sodium ion, but it can't stabilize the ethoxide because there's no protons in order to interact with the negatively charged oxygen. And so the reaction at the top will proceed faster with the consideration of SN2, because at the end of the day, the reaction at top has higher energy reactants. The reaction at the bottom has lower energy reactants, and it goes to essentially the same transition state. So the activation energy of the reaction below is higher, which means that it's slower. It proceeds slower kinetically. Okay, so now what about the products? Well, remember that in an SN2 reaction, we're going to have a trigonal bipyramidal transition state, which leads to an inversion in the stereochemistry because of the attacking nucleophile attacking at the same time the leaving group is leaving. So we want to be able to show that result. So I need to reverse the stereochemistry of that carbon. And so this would be my product. Okay.